Jai Hind, dear students. Hope you all are doing well. As we have learned square numbers, and I believe you also have done question based on that. So today we are going to learn about Pythagorean triplets. So a collection of three numbers such that the sum of square of the smaller two numbers is equal to the square of the third number. As we have also learned that according to Pythagorean theorem, in a right angle triangle, the square of hypotenuse is equal to the sum of the square of the perpendicular and the base. So basically it is a collection of three numbers or set of three numbers which follows Pythagorean theorem, and it must satisfy the rule. Also in general, Pythagorean triplet is in the form of 2m square plus m square minus 1 whole square, which will be equal to m square plus 1 whole square. Clear? Where the first number is 2m, second number is m square minus 1, and the third number will be m square plus 1. Also m square plus 1 will be your hypotenuse as it is longest side. So how to find Pythagorean triplets when any one number is given? Let us suppose that for any natural number m, where m is greater than 1, holds this relation, where we have 2m whole square plus m square minus 1 whole square, which will be equal to m square plus 1 whole square. Let us quickly verify if LHS is equals to RHS. So to find LHS, what we need to do? First of all, we will solve left hand side. So in left hand side we have 2m whole square, that gives you 4m square, plus m square minus 1 whole square. Here we will use a minus b whole square formula, which is a square plus b square minus 2ab. So keeping this formula in mind, a square, it means that m square will gives you m square whole square. Clear how we are getting? Then plus b square, that is 1 square, minus 2ab, 2 times m square, that is a, times 1, that will give same answer. Now solving further, 4m square plus m square to the power square, m to the power 4, plus 1 minus 2m square. Clear? Now check the variables. M square and 2m square minus 2m square is having same variable, so we will reduce it. Okay, first of all let us write m to the power 4, and then 4 minus 2 is plus 2, variable will be same, plus 1. Now if you will further simplify it, you will notice that this is the square of a plus b whole square, where a is m square and b is 1. Right? See, a square plus 1 whole square will gives you m square whole square, that is m to the power 4, plus b square, that is 1 square, and we are getting 1 also, plus 2ab, 2 times of m square times of 1. So in this way we have verified this triplet. So whenever we are talking about Pythagoras triplet, then we can say that we remember Pythagoras theorem, isn't it? So according to Pythagoras theorem, suppose we have any right angle triangle and all the three sides are defined in such a way that, let's take perpendicular as A, base as B, and hypotenuse as C. And also let's give name to this triangle. PQR is a right angle triangle and angle Q is 90 degree. So that now we can say that PQR is a right angle triangle. Now according to theorem we can say that square of perpendicular plus square of base will be equal to square of hypotenuse. Right, we have learned this. So this is the Pythagoras theorem, and based on this only Pythagorean triplets are formed. Basically Pythagorean triplet says that what three number a, b, c would be there that can perfectly satisfy this formula. Let's again take any random value of A, for B and for C. So now we will see that these three combination of numbers can satisfy this formula or not. So let's check out. To make it satisfied, what we need to do? Just put all the values of A, B, C in this formula, and we will check either LHS is equals to RHS or not. So this is the formula. Now putting A is equals to 3, so it will be 3 square plus B square, that is 4 square, will be equal to 9 plus 16, and 9 plus 16 is 25. Now solving right hand side, that is your C square. C is 5 square, and as we know 5 square is 25. So here you can see that left hand side is satisfied to right hand side. And on this basis we can say that yes, this triplet satisfy this equation. So this is only Pythagoras triplets. What three numbers are there which can satisfy the equation will be called Pythagorean triplets. So this is just combination of three numbers which satisfy the equation. Now let's see how many more triplets are there we have. So as we know, the formula is A square plus B square, which is equals to C square. This is Pythagoras theorem. So there are numbers which can satisfy this equation. Let's write it as A, B, C. If we will take A as 5, B as 12 and C as 13, then these triplets will satisfy the equation. A as 7, B as 24 and C as 25. This will also satisfy. And these are more triplets. Now the upper three triplets are very common, and you can see as an examples also. So they are the list of all the triplets which can satisfy this equation. So for your better understanding, you can refer to the list. So all the numbers over here are easily satisfy the equation, and these are here just for you better understanding. You can randomly select any number and can check for it. Now the second thing is here, dear students, that you can also think in the reverse way. It means that whenever any triplet is given to you, or let's suppose try this. Suppose we have any triplet as 3, 4 and 5. These are the triplets, and suppose it's given that these three are sides of the triangle. From here we can also take one understanding that if these three sides can form triangle, then any one of these can also form right angle triangle. Right? Now the question is, triplet is already given to you, right? And from this given part you have to reach to the right angle triangle. That previously what we have studied, that if right angle triangle is given, then how we reach to the triplets. Now we need to find that if triplets are given, then how we will find the right angle triangle. We have to find the reverse. So let us find the understanding behind this. Let us find that how we'll get right angle triangle from this triplets. Now we will see what more things we can understand by this. Let us take previous example, that was 3, 4 and 5. Assuming as A, B and C. And how we satisfied the triplets? By satisfying that A square plus B square should be equal to C square. Now let us check this list. If you will go through this list, one thing you will observe that one of the number in each combination is a prime number, like here 13, 7, 17, 41, here 61, 37, 63, 29 and in this 53. See how amazing it is. So now we can conclude that nearly every set of the numbers in this list have one prime number. And secondly, what we can observe is that there is one even number also in the set. like 12, 24, 8, 40, 12, 16, 20 and 28. So these are the two observations that we have got. And one more very important thing is to note that the triplets what we have, the multiples of this triplet will also satisfy the Pythagoras theorem. Like if we multiply 3 by 2 we will get 6, 4 by 2 we will get 8, 5 by 2 we will get 10. And see, 6, 8, 10, this set of numbers is also Pythagorean triplet. Now let's do it. 8 square will be 64 and 10 square is 100. Now 36 plus 64 is 100. As you can see, it satisfied. So what we can conclude that the multiples of the Pythagorean triplets also satisfy Pythagoras theorem. Let's take one more multiple in this case. So let's take 5. So if we will multiply 5 by 3 we'll get 15. 4 times 5 is 20 and 5 times 5 is 25. So again let's check it will satisfy or not. So we will get 225, 400 we will get 625. So yes, it is satisfying. It means that the multiples of the Pythagorean triplets are satisfying Pythagoras theorem. So I hope so your concept is clear regarding these two multiples that we have taken. Now in this list let me tell you 16, 63 and 65. This is also the case of multiples. I think so your concepts are clear. So in this way we can understand the basic concepts of triplet and how we can use these concepts in our question. Also I will suggest that for better understanding of the concept, try to find more Pythagorean triplets. So we will learn more in our next class. Till then, thank you and take care.